Hi, Ashley. So yes, I can create a short video here. So to start off, we have the square root of x plus square root of y equals 1, which is the original equation. And we want to find the second derivative of this equation here. And so to start off, we can rewrite the square root of x plus square root of y equals 1 using exponents. And the way we can do that is we know that we have a power of 1 here, anything that the first power is itself, and we have a root of 2, hence square root, and therefore, as a fractional exponent, that would be the same thing as taking x to the 1/2 power. Same thing with y. A square root would indicate that I'm taking y to the 1/2 power, and that equals 1. So that's how we rewrite it here. Now, once we rewrite it, that will give us the ability to use the power rule of derivatives to find the first derivative. And when we do so, we're going to take the 1/2 multiplied by the coefficient, which of course is 1. So 1/2 times 1, which is 1/2, times x, and then raise that to 1 degree lower than the current exponent of 1/2, which will get us an exponent of negative 1/2. Plus, we're going to do the same thing with this term, y to the 1/2. Taking the first derivative will give us 1/2 y to the negative 1/2 times the derivative of y itself, which is dy over dx. And then the derivative of 1 is 0, since it's a constant. So that is going to all equal 0. Now, let's solve for dy over dx now. And we can do so by first subtracting 1/2 x to the negative 1/2 power to the other side. So I'm going to do just that. So that will be giving us 1/2 y to the negative 1/2 power times dy over dx. And that is going to equal negative 1/2 x to the negative 1/2 power. All right. And then we can divide both sides by 1/2 y to the negative 1/2 power. And notice how the 1/2s are going to cancel out here. Y to the negative 1/2 is going to move this back to the top, which is going to give us y to the 1/2. This x to the negative 1/2 is going to bring this down to the bottom if we rewrite it using positive exponents. So x to the 1/2 down here. And this negative is still here, of course. So dy over dx, excuse me, is therefore going to equal negative y to the 1/2 power over x to the 1/2 power. All right. Now, dy over dx would be the same thing as writing it as y prime, which indicates that this is the first derivative. Of course, we're looking for the second derivative, so I'm going to go to the second board to illustrate how we're going to do that. Starting off with the first derivative, negative y to the 1/2 over x to the 1/2. We can now use the quotient rule of derivatives to help us get that second derivative. And the quotient rule of derivatives tells us to imagine u being equal to the numerator for just a moment and v being equal to the denominator for just a moment, x to the 1/2. It's going to tell us to take the derivative of the numerator, which is the negative y to the 1/2, times the denominator, x to the 1/2, subtract that by the derivative of the denominator, x to the 1/2, times the numerator, negative y to the 1/2, all over the denominator squared. So x to the 1/2 squared. All right. Well, if I take the derivative of the numerator, negative y to the 1/2, that's going to get us negative 1/2 times y to the negative 1/2. Notice how we use the power rule here. Multiply that by dy over dx, the derivative of y, and then multiply by the denominator, x to the 1/2 power. Subtract that by the the derivative of the denominator, which is 1/2 x to the negative 1/2, again using the power rule. Multiply that by the numerator, negative y to the 1/2 power. And all over the denominator squared, x to the 1/2 to the second power. All right. Now, we know that dy over dx is equal to negative y to the 1/2 over x to the 1/2. So notice how I can rewrite this and substitute with this down here. All right. So substituting, now we have negative 1/2 y to the negative 1/2 power times negative y to the 1/2 over x to the 1/2, the derivative, the first derivative. Multiply that by x to the 1/2, and the rest is the same here on the right side. X to the 1/2 power squared, we know that we multiply exponents when we raise an exponent to an exponent, and therefore 1/2 times 2 is equal to 1, so x to the first power. All right. Okay, so now what we can do from this point forward is notice how the x to the 1/2 powers are going to cancel out. And notice how the y to the 1/2 powers are also going to cancel out, because this would be moved to the denominator with that negative exponent, which would be the same thing as 1 over y to the 1/2. So notice how you would have a y to the 1/2 in the numerator, y to the 1/2 in the denominator, and that's going to cancel out as well. We also have a negative times a negative, however, so that's going to give us a positive 1/2. So notice how we have the negative multiplied by negative here, which is going to get us a positive 1/2. All right. Now on the right side, notice how we have a negative multiplied by a negative as well, which is also going to get us a positive. So if I rewrite this entire thing, I'm going to end up with 1/2 plus 1/2 times x to the negative 1/2 y to the 1/2 all over x. Now notice at this point, I can multiply the top and the bottom, the numerator and the denominator, by 2, and that will help me get rid of the fractions up here at the top. That way we don't have a fraction over another fraction, or for a fraction within a fraction, I should say. And that will simplify things a little bit more for us when we do it that way. So now if I multiply the top and the bottom by 2, as I just mentioned, that's going to get us 1 plus x to the negative 1/2 y to the 1/2 all over 2x, because we're, again, multiplying the top and the bottom by 2. All right. Now remember that a negative exponent indicates division, so that moves to the denominator. So now I have 1 plus y to the 1/2 over x to the 1/2 over 2x. If I want to add fractions, we know that we need a common denominator for that. So x to the 1/2 is the common denominator in this instance. So I'm going to rewrite the 1 as x to the 1/2 over x to the 1/2. And that will, combined as a fraction on the top, get us x to the 1/2 plus y to the 1/2 all over x to the 1/2. And then this is 2x on the bottom. All right. Now, remember that x to the 1/2 power plus y to the 1/2 power is the same thing as saying the square root of x plus square root of y. And recall that this was equal to 1 from the original equation. So I can replace this whole thing as 1. So rewriting this as a square root as well, I'm going to end up with 1 over the square root of x over 2x. And we know that when we divide by a fraction, that's the same thing as multiplying by the reciprocal. So 1 over square root of x times the reciprocal of 2x is going to be 1 over 2x. And that's going to get us our second derivative in its simplest form, 1 over 2x times square root of x. Hopefully that was helpful. If you have any other questions, definitely let me know. But otherwise, that's how we find the second derivative. Have a great night. Thank you.